Alright, this video is all about what I would collectively call the kinematics equations. Kinematics refers in general to just motion equations, things about motion. That's what kinematics is, the study of motion. So, we have got in the second half of the section 5 characters. Delta x, as seen here, vi, vf, time, and acceleration. With these 5 characters, we can recombine them in any number of different ways based on the previous equations we've already learned and work them in different ways to find different things. For example, this equation here comes from the average velocity equation. When you look at this portion of it right here, if we add vf and vi together and divide by 2, we are averaging the velocity. And if you look at the old equations, where you could say that delta x equaled average velocity times time. So it's the same equation, just rewritten. So if I'm given a final velocity and initial velocity, I'd divide that by 2, and I'd multiply by the time that this velocity change happened for, and it'd tell me how far I went. Looking at the next equation, actually 2 equations. This comes from this is the acceleration equation written over again. Think of it, if you had acceleration equals vf minus vi over t, you would, if you multiplied the t over and you then added your vi over, all of a sudden this is what it looks like. What this means is, how fast was I going if I started out with a certain speed and accelerated for a time? So accelerating for a given time will give you a certain velocity. You have to add on how fast you were initially going to get the proper final velocity. If we look over here, how far could I have gone if I had an initial velocity, and if I just go with no acceleration, if this is 0, then my initial velocity times a certain amount of time gives me how far I go. But because I am accelerating over, I need this half of the equation. On this half of the equation, because I accelerated for a given time, I went farther than had I not accelerated. Let's take a peek at the units for a second. Over here, V final, of course, is in meters per second, and we're going to want to get more meters per second out of it. And so meters per second is over here. We're going to add other things. These other things have to come out to meters per second. So if we take meters per square second and we multiply that by seconds, all of a sudden, because these are truly in the denominator, they cancel out, leaving you meters per second. So meters per second plus meters per second equals meters per second. And that's what we want. Well, we can kind of do the same thing right here. We're looking for meters there. We have meters per second times seconds, which would cancel out the seconds. Put that there. And over here we'd have meters per square second, and we'd have seconds that are getting squared, which would kill those, leaving you meters and meters and meters, giving you meters. Again, these are tools to use the variables given in a problem to solve for an answer. In this problem, V final is perhaps being asked for. If we have a VI, if we have an acceleration and a time, we can find how fast we're going. We can find how far we would go after an acceleration if we know how long we were accelerating for and we know how fast we were initially going. And the last one here, how fast might we be going if we accelerate over a certain distance? And maybe we have a VI thrown in. Again, there are little quirks with each equation, especially when you look at all these equations. Let's look at one final page here. As you look at the 4 equations I just gave you, in any given one of these, if the initial velocity is 0, which is not that uncommon for us to do a problem where something starts from rest, the equations are so much easier to work. Vi is 0, Vi is 0, Vi is 0, Vi is 0. They're very much easier to work with. The same goes with Vf. If I have no final velocity, it eliminates a chunk of the equation. Now, when do I use which one? When I look at a problem, and I'm reading through the problem, okay, I'm reading through, and I see something about a distance, I see something about how fast I was going beforehand, I see something about how fast I was going at the end, and I know how long I was going. The one thing that's missing out of that one, we have 5 characters. We are missing acceleration in this first equation. So if you're reading a question and there's no acceleration given, but you have these other items, this is the equation to use. When you look at this one, I'm given some sort of distance, some sort of initial velocity, a time, and an acceleration. But you read nothing about the final velocity. This is the one you're looking for. Down here, there's no mention of a displacement in this equation. There's no mention of displacement here. And down here, you'll notice there's no mention of time in this equation. So, what that says to me is when you're reading one of these equations, there has to be these four of the 5 characters given in the problem. One is going to be your question mark, and 3 other ones are given. One of them, usually one of the velocities, is going to be a 0. That's very typical for the one velocity to be 0. Either it starts from rest or it goes to a stop.